Okay, so we were discussing the speculative demand for money, correct? And we have this formula for bond prices. V is equal to F divided by 1 plus the rate of interest to the power t. And this, of course, implies that since F and t are fixed at any point in time, there is a negative relationship between V and R. That's what's coming out of this formula for bond prices, correct? Now, what is the speculative demand for money again? This is money held in order to avoid making a capital loss in bonds, meaning that if you expect bond prices to come tumbling down in the near future, you will be afraid to hold bonds today. Is that correct? So if your expectation is that bond prices are going to fall in the future, that's when you will get out of bonds and into money as far as your wealth portfolio goes. Remember that people have a certain amount of wealth and they would like to divide it between bonds and money. Bonds earn interest, that's a good thing, but the negative about them is that they can lose value. Their prices could fall. Money earns no interest, that's a bad thing, but the good thing about money is that it is a safe asset. It's a dollar in your pocket shall remain a dollar in your pocket. Correct? So when bond prices are expected to fall, if these prices are expected to fall, what will people do with their wealth portfolio? They will try to get out of bonds and into money. Is that correct? So the speculative demand for money is going to rise when people expect bond prices to fall. They're expecting it to fall, and therefore they're getting out of bonds and into money. Is that correct? So let me write this down. When bond prices are expected to fall, the speculative demand for money rises. People want to get into safe money. Does that make sense? On the other hand, when bond prices are expected to, if I replace this word fall by rise, if people expect bond prices to rise, what would happen? They would want to buy bonds today in the expectation of making a capital gain in the future. So then you'd have a movement in this direction, meaning people will try to convert their money into bonds before the prices rise. Right? So when bond prices are expected to rise, the speculative demand for money, what do I put here? Falls. Right? Now let's discuss the way people form expectations. So the question now is, how do people form expectations? Well, we are going to make a simple statement here. Okay? And this is a pretty reasonable way about how people form expectations about anything, not just bond prices. We all have a sense of what is normal. We have a sense of what is normal. And if reality deviates from this normal, then our expectation will be that things will come back to normal. Okay? Does that make sense? So for instance, if today were an unnaturally warm day, if temperatures today reach, let's say, 105 degrees, which is unnaturally warm, what would our expectation be about temperatures in the near future? If today were exceedingly warm, we would expect temperatures in the near future to fall to normal. Exactly. On the other hand, if today were unnaturally cold, we would expect temperatures to rise in the near future. So that's our simple statement about how people make expectations. We have a sense of what is normal. right? All right. So therefore, if people believe that bond prices today are unnaturally high, what will their expectation be about bond prices in the future? They will expect these prices to fall in the future. And if they expect these prices to fall in the future, what does that do to their speculative demand for money? This will imply that their speculative demand for money shall be high. Is that correct? Because when you expect bond prices to fall, what do? You get out of bonds and into money. Does that make sense? So if people believe that bond prices today are unnaturally high, they will expect these prices to fall in the future. And this will make them then increase their money holdings. Right? They would get out of bonds because they expect bond prices to fall. Does that make sense? Now, let's bring in the interest rate. So bond prices today are unnaturally high. Now, what is the implication for the interest rate? If prices are high, what is the interest rate today then? Remember, you have this. Is that correct? We have a negative relationship between V and R. So if V is very high, this must imply that R is very low. Is that right? Because we have a negative relationship between bond prices and the rate of interest. If bond prices today are very high, this must imply that the interest rate today is very low, because we have this relationship between bond prices and the rate of interest. Does that make sense? So if bond prices today are very high, that means interest rates today are very low. Now, if bond prices are very high, we expect them to fall. If we expect them to fall, we will hold more money in our wealth portfolio. In other words, our speculative demand for money shall be high. So we then have this relationship then. R low, speculative demand for money high. Make sense? That statement makes sense to you? When R is low, it means V is very high. The speculative demand for money is going to be high because people will expect bond prices to fall in the near future. Is that correct? On the other hand, if people believe that bond prices today are unnaturally, I'm going to replace this word here by unnaturally low, then people will expect bond prices to rise in the future. Is that correct? And so their speculative demand for money shall be low. Now let me explain that. If bond prices today are unnaturally low, then of course the way humans make expectations is that we will expect bond prices to go up in the future. And if they are expected to go up in the future, what would we do? We would try to buy bonds today, because if we buy them cheap today and the prices go up in the future, we will make a capital gain. Is that right? So if bond prices today are unnaturally low, our speculative demand for money shall be low. Is that correct? Now, bond prices being very low means interest rates are very high. Correct? So then we can say that when R is high, well, this is going to lead to the speculative demand for money being low. Now, did we all get that? Yes? So it all depends on how people perceive bond prices today. If they're considered unnaturally high, then of course they will be expected to fall in the future, in which case people will be holding a lot of money. Now, bond prices being very high translates to interest rate being very low. So we can therefore now, using these statements here, we can draw a speculative demand curve for money, just as we drew the transactions demand curve for money and the precautionary demand curve for money. Okay? And what will that curve look like? Given that we have now established that when the interest rate's low, bond price is very high, and so people are holding a lot of money today in the expectation the bond prices should fall in the future. Is that correct? So if this here is the quantity of money being held for speculation, and this is the rate of interest, a high rate of interest is going to combine with a low quantity demanded of money for speculative purposes. A low interest rate, on the other hand, is going to combine with a high quantity of money demanded for speculative purposes. Does that make sense? So we're going to have combinations like this. This could be a point, and this could be a point. Does that make sense? Where does that come from? That comes from this statement that we made here on this side. Is that correct? Right? So if we were to draw a line then between these 2 points, well, that then gives us the money demand for speculation curve. Now notice that it looks much like the other 2 demand curves for money, the transactions demand curve and the precautionary demand curve. They all look the same, negatively sloped. Only the reason why the transactions demand curve for money is negatively sloped, meaning when the interest rate rises, why do people hold less money for transactions? Well, there the reason was that the higher rate of interest is like a higher implicit cost of holding money because you're losing more interest income. So a high interest rate then discourages you from holding money because holding money is expensive. That was the argument there. But here in this diagram, the argument's different. A high interest rate in this case translates to low bond prices. If bond prices are low, people expect them to rise, and so they are holding very little money and a lot of bonds in their wealth portfolios. You see, the logic here is different. A high interest rate in this diagram does not speak of a higher implicit cost rate. That's not what's driving this. What's driving this is the relationship between the interest rate and bond prices. Am I making sense? Right? So even though this curve looks like the other 2 curves, the logic behind this negative relationship is quite different than the logic underlying the negative slopes of the transactions demand curve for money and the precautionary demand curve for money. You follow? So there the reasons are quite simple. A high interest rate means holding money is more expensive. Hence, hold less money. Right? Here it's different. Here it's saying a high interest rate translates to low bond prices. If bond prices are low, people expect them to rise, and so they hold very little money, more bonds, in the expectation of higher bond prices, in the expectation of capital gains, in other words. Right? So we have those 2 other demand curves. We have the transactions demand curve, and we have the precautionary demand curve. And now here we have the speculative demand curve. So what is our combined demand curve for money going to look like? It's going to be these 3 added up. These 3 added up. Now, how do you add up demand curves? Do you remember? From the early part of our course? How do we add up demand curves? We add them up sideways. In other words, at this interest rate, this is the transactions demand for money. At that same interest rate, this is the precautionary demand for money. So what are the two combined? You'll be adding up these two distances sideways. Is that correct? And we do that for the third demand curve also, the speculative demand curve. So when you add up these three demand curves, we end up then with a combined demand curve that looks exactly like this. Since all three components are shaped the same way, their sum is going to be shaped like any one of them, right? Only it'll be further to the right. Yes? And so that will bring us to the money demand curve. And let me show you what this money demand curve is by going back to our PowerPoint. So in the end, we have this money demand curve here, which is the three demand curves added up. Right? So now we have an understanding of where this money demand curve comes from, correct? Why is there this negative relationship between the rate of interest and the quantity demanded of money by us? Now we come to the money supply curve. The money supply curve in this diagram is a vertical line. Now, why is it a vertical line? In other words, the supply of money doesn't depend on the rate of interest. That's why it's a vertical line. Now, why doesn't it depend on the rate of interest? Because this is a result of deliberate Fed policy. The Fed decides what the money supply is going to be. It simply makes a decision, and that decision doesn't depend on things like the rate of interest. Follow? So we have a money supply curve that is completely vertical, and this is controlled by whom? The Fed. Now let's discuss money market equilibrium. So where do we have money market equilibrium? Where these two curves intersect, right there. Right, so let's talk about money market equilibrium now. Okay? Why is that the equilibrium? Well, to understand why that is equilibrium, let's start with a situation of disequilibrium. And let's see how the money market will then come to equilibrium. So let us start with an interest rate of R1. If the interest rate were currently R1, what would be the quantity demanded of money? The quantity demanded of money, of course, could be read off the money demand curve. So we'd hit the money demand curve like this and then down to the quantity axis. And so I'm going to call this MD1. That's the quantity of money demanded at that rate of interest. What's the quantity of money supplied by the Fed? MS. So what is this gap then? Well, we typically call things, when the quantity supplied is bigger than the quantity demanded, we refer to that gap there as a surplus, correct? A surplus of money, also sometimes called an excess supply. Now, what is meant by the excess supply of money? And before I discuss this, let's say we're talking about a market for beef, okay? We have a market for beef, right? And let's say that the price of beef is B1. At that price of beef, what's going to be the quantity demanded of beef? Well, you could read it off this curve like this. So that would be the quantity demanded of beef. What would be the quantity supplied of beef? That would be the quantity supplied of beef. So we have here an excess supply or surplus of beef, right? Who has the surplus? Who is actually in possession of that surplus beef? Buyers or sellers? Sellers, of course, correct? It's the ranchers, for instance, would be stuck with all their unsold beef. Right? But in our money market, the situation is quite different. Why is it different? Because what is money supply defined as? Let's look at the M1 definition of money supply. It consists of cash with the public. It consists of the checkable deposits of the public, right? And lastly, travelers' checks with the public. Is that correct? In other words, MS is already with us. Money supply is already with us. Correct? Unlike the surplus beef that lies with the beef producers, not consumers. In this case, the money supply is already with us. So how do we interpret this surplus money? How do we think about this excess supply of money? MS is the money that we currently hold. But we would like to hold less. That's how you think about this. MS is what we hold, but MD is what we'd like to hold. Do you follow? That is what we'd like to hold, but we're holding more than we'd like at this point. In other words, if you think about our wealth portfolio, this is our wealth portfolio, right? How much of this are we holding in cash form now, or in money form? Let's say we're holding this in money form. But that is more than we'd like to hold. What we'd like to hold is perhaps less. We'd like to hold only this much in the form of money, but we're holding more than we'd like. Does that make sense? So if we're holding more money than we'd like to hold, what would we do with our excess money? We would, remember, we'd like to keep this balance in our wealth between bonds and money. Right now, this is imbalanced. We have too much money in that mix. Am I correct? If we have too much money in that mix, what would we like to do to straighten that balance? Buy bonds with some of that money. Is that correct? So when we have too much money in our wealth portfolio, we will buy bonds with that surplus money. Does that make sense to you? Okay. So when people start to buy bonds with surplus money, when people buy bonds with surplus money, what does that do to bond prices? When people buy more of anything, what happens to that item, the price of that item, rather? It goes up, doesn't it? We've learned that from simple demand-supply analysis. So when people start to buy bonds with their surplus money, this will drive up bond prices. Now, if bond prices rise, what's the implication for the rate of interest? Remember, we have a negative relationship between V and R, correct? So if V rises, R must fall. Is that right? So therefore, this rate of interest R1 starts to fall, like that. And when does this fall in the rate of interest stop? Once the rate of interest reaches R star. Because once the rate of interest reaches R star, there is no longer an excess supply of money. People are no longer going to be trying to get rid of their excess money by buying bonds. And so there will no longer be an upward pressure on bond prices. Is that clear? So this is how the money market comes to equilibrium. Now let us discuss this whole thing again, starting from a rate of interest that's lower than R star. So let's say we start with a rate of interest here, let's call it R2. If the rate of interest were R2, what's going to be true? Well, now the quantity supplied of money, or rather the quantity demanded of money shall be MD2, whereas the quantity supplied of money remains MS. So now what do we have? This is a shortage. A shortage of money. How do we interpret that? Well, right now, people are holding how much money? MS, by definition, because it's all already with us. Is that correct? So we're holding MS, but we'd like to hold more. This means that in terms of our wealth portfolio, there is too little money in it from our point of view. We'd like there to be more money in our wealth portfolio. In other words, we have too much bonds and too little money. So when there's too much bonds and too little money, what would we want to do? Sell bonds. And when we sell bonds, bond prices will be reduced as people start dumping their bonds on the market. And this will then result in the rate of interest rising because of that negative relationship between bond prices and the rate of interest. And so the rate of interest starts to climb like that. And when does it stop? When the rate of interest reaches R star, because once it reaches R star, there is no longer a shortage of money. People are no longer going to be dumping their bonds on the market, depressing bond prices. Right, so this is how the money market comes to equilibrium. Right? Let's get back to monetary policy now. Let's get back to monetary policy now, okay? So let's say that we have a recession or a recessionary gap. Which the Fed wishes to narrow. If there is a recessionary gap, what is called for? We need AD to increase. We need AD to increase. We know this. Am I correct? How do we stimulate demand? How does the Fed stimulate demand? This is what the Fed will do. Fed will increase the money supply. We know that when the money supply is increased, what happens to the rate of interest? Well, we can draw a little money market diagram here to make sure you understand what's going on. Quantity of money, rate of interest, money supply curve, money demand curve. And we have equilibrium where these two intersect, so that brings us to the equilibrium rate of interest R star. So what would the Fed do in a recession? The Fed would raise the money supply, meaning shift this money supply curve to the right like this. Yes? And when the money supply curve shifts to the right like that, we end up with a new equilibrium right there, which translates then to a lower equilibrium rate of interest R double star. Yes? So an increase in the money supply causes the rate of interest to fall, the equilibrium rate of interest, that is. Right? This then stimulates consumption spending, investment spending, and also net exports, as we've learned. Right? For instance, with a lower rate of interest, you and I are more likely to go shopping on credit, and businesses too are more likely to buy new machines on credit, etc. Right? So this then means that AD has gone up because all of these three are components of aggregate demand. Right? And when AD goes up, what happens to the recessionary gap? It shrinks. And what's the relevant diagram there? We need the goods market diagram to explain that, correct? Real GDP, price level, aggregate demand, aggregate supply. And we have now a rightward shift in aggregate demand like this. Is that correct? What does that do? Well, the old equilibrium GDP was Y star. The new equilibrium GDP shall be Y double star. And if, let's say, this here is YF, potential GDP or full employment GDP, the old recessionary gap was that big, but now it's shrunk The recessionary gap has been narrowed to just that as a result of the Fed's expansion of the money supply. Correct? So we can then we can also write, you can go like this, AD going up, Y star going up. Right? Now in this picture here, which parts happen in the money market, which parts happen in the goods market? Of this sequence of events, which events occur in the money market and which events occur in the goods market? Well, these events occur in the money market. Is that correct? So this happens in the money market. What events happen in the goods market? Is that right? So these events happen in the goods market. The connection between the money market and the goods market has a name, this connection, you see? This is the connection between the two markets. And this is called the transmission mechanism. This is the transmission mechanism. This is how events in the money market are transmitted to the goods market. Right? Now, when we were discussing fiscal policy, we discussed crowding out. Do you remember the phenomena of crowding out? Crowding out was when an increase in G caused the sum of C, I, and X minus M to fall. And what does crowding out do? Crowding out weakens the effect of fiscal policy. How's that? Because let's say the government increases its spending as part of expansionary fiscal policy. The AD curve shifts to the right, but then because of crowding out, because these other three spendings are reducing, the AD curve shifts back leftwards. Make sense? So in the end, we end up with a smaller reduction in the recessionary gap than anticipated. Right? Crowding out reduces the effectiveness of fiscal policy, right? Let's now discuss factors that would reduce the effectiveness of monetary policy. What factors might reduce the strength of these links here? What factors would cause a weakening of these connections? What would cause a weakening of monetary policy? Let's talk about that. Okay? So what factors might cause a weakening of this? Well, one factor would be, what if this transmission mechanism were weak? What if the connection between the money market and the goods market were weakened? And let me tell you how this might happen. How is this supposed to work? It's supposed to work with the interest rate falling, and that's stimulating these three spendings. Correct? Now, let's say that a car dealership in town starts offering 0% interest on car loans. You often see ads like this on TV, do you not? 0% APR on car loans. Is that the only factor that's going to cause you to go out there and buy a new car? Simply because the interest rate is 0%, are you simply just going to get up and run and buy a new car only because of that? Or are there other factors that play a role in your decision? There are other factors that play a role, am I correct? The interest rate is just one of many factors. Let's say that your boss at work has hinted that there will be downsizing going on at your firm, and lots of people are going to lose their jobs. And you may be one of them, right? And at the same time, the local Honda dealership reduces its interest rate to 0%. Are you going to go there and buy a new Honda with this dark cloud over your head that you may lose your job in the near future? That's my point, you see? So if the interest rate were lowered and people were very pessimistic about the future, this lowering of the interest rate may not be enough to get them shopping, my point is. You see? So if you have a pessimistic environment, let's say that businesses too are pessimistic, consumers are pessimistic, about the future. A lowering of interest rates isn't going to get them running to the stores. You follow me? So that's why the transmission mechanism, in fact, become quite weak when there is a lot of pessimism in the economy. Does that make sense? So this connection may become weak is one point. So I'm going to put a little cross here. So that's one reason why monetary policy may become weak. The other possibility is that is this one here. What if the money supply is increased by the Fed, but that doesn't cause the interest rate to fall? And this is a very peculiar situation. And I'm going to see if I have a diagram here that explains it. Yes, here we go. So here we have a money demand curve, but this is slightly peculiar because instead of continually decreasing, instead of the curve going down like that, as we would expect, this money demand curve has a flat section at its lower regions. This, by the way, is called a liquidity trap. Sometimes money demand curves can have that kind of shape. And now you notice, if the Fed increases the money supply from MS to MS prime, in other words, if this money supply curve is shifted to the right, what happens to the equilibrium rate of interest? It doesn't fall. So that's another reason that may cause monetary policy to become less effective. Correct? I'm going to talk about yet one more factor that may weaken monetary policy. And that is, let me go one step behind this. Okay? So let me now go one step behind this. What would cause the money supply to rise? What would cause the money supply to rise? Well, you think of the three ways in which the Fed does this. Buying bonds, lowering the RRR, lowering the discount rate, correct? Principally, buying bonds. That's the main way in which the Fed increases the money supply. So what if the Fed buys bonds? Now, what's the formula for a change in the money supply? The formula is change in the money supply is equal to change in the monetary base times the money multiplier. Is that correct? Recall this? Now, what's the money multiplier? The full formula for the money multiplier, to remember, is 1 plus C divided by R plus C. That's the full form. Now, what's C? C is the cash to deposit ratio. R is bank's desired reserve ratio, which may exceed the required reserve ratio. Right? Now, what happens when bank's desired reserve ratio becomes very high? If banks want to hold a very large percentage of their customers' deposits as cash, what is that going to do to the money multiplier? Mathematically, if R rises, well, that would cause the denominator of that expression to become bigger. And if the denominator becomes bigger, that means the multiplier becomes smaller. Am I correct? So let's say the Fed buys a huge amount of bonds and injects a lot of monetary base into the economy. But if banks want to hold a very large percentage of their customers' deposits as cash, this injection of monetary base is going to result in a very modest increase in the money supply. Do you follow me? And this is, in fact, what happened during our last recession. You see, because of so many mortgage loans going bad, people walking away from their mortgage loans. Why? Because the housing market collapsed. Let's say you took a loan to buy this expensive home, and then a few months later the price of the home plummeted, and now you owe more than the value of the home. What do? A lot of people find it rational to simply walk away from the home, walk away from the loan, default, in other words. Right? Now, when you had lots of defaults going on, banks began to be worried about their liquidity position. When you make a lot of bad loans, you've lost a lot of money. And now you're worried that if your customers, your depositors, come to withdraw money from you, you won't have enough to pay them. You follow me? So you want to hold a lot of cash at this point. You're reluctant to make loans even. And so that drives up the R there, the desired reserve ratio. And that causes the money multiplier to become smaller. And this means that when the Fed attempts to increase the money supply by buying bonds, its efforts are not going to be very successful in the sense that the money supply will increase very modestly. And if the money supply increases very modestly, then of course interest rates will fall only very little. And if interest rates fall very little, then consumption spending, investment spending, and net exports will be stimulated very little. And the AD curve should shift to the right by very little. Does that make sense? We will stop here today.